Hello everyone, welcome back to Open Source for Geeks. This is continuation of my series on understanding Python concepts. So in the last video, we saw how to write a class and some of the basic information of what entails a class, instance variables, class variables, and other related concepts. In this video, I'm going to explain what are static methods, what are class methods, and how do we use data class decorator to write a class in a more compact manner. So let's go back to our PyCharm, and this is the employee class that we had written last time. We have instance variables, which is name and age, and we have a class variable called maxAge. So let's start by writing static methods and class methods. So if you are from a Java background, you might be using these words interchangeably. Both kind of mean the same thing in case of Java, where the method actually belongs to the class instead of object of the class. However, in Python, static method and class method mean two different things. Static method is a method that belongs to the class, but it actually does not have a reference to the class. And I'll explain that in a while. Whereas class method is again a method that belongs to a class, but it has references to the class instance and it can access and edit class variables. So let's try to see an example. So let me write a method called, let's say, get twice max age. Now, if you see, by default, it takes an argument called self, which means it's an instance method. Now, we want this to be a class method. So what we will do is we will decorate it with a decorator called class method. Now, once you do that, it is going to take another implicit argument called CLS. This is nothing but a reference to the class. Unlike instance method, which takes self implicit argument, which is a reference to the object of that class, CLS is the reference to the class itself. So let's say this returns an integer, and in the method, let's return max age into 2. And as you can see, it has a reference to the class, so we can directly use that reference here. So now you see it has the method is completed. So you decorate the method with the annotation at the rate class method to make it define it as a class method. Once you do that, it will take an implicit argument called CLS, which is a reference to the class. And then inside the method, you can reference class instances using the reference. Similarly, you can also update your class instance variables, class variables using the same reference. Like here, you could say cls.maxage is equal to, let's say, 300. So you could do that as well. Now let's try to see what are static methods. So static methods are methods that belong to a class, but they don't have a reference to the class itself. So these are type of methods that you would typically use to write some utility methods that really do not concern itself with, let's say, the instance of the object or in this case, let's say we write a simple method, utility method, which says is same name, and then we decorate it with static method. Now, once you do that, you will see that it does not take any implicit argument, but you can pass any other arguments that you want. So let's say I pass name1 and let's say name2, and each of these are, let's say, string arguments that you pass, and then it returns, let's say, a boolean value. And the method implementation is very straightforward. It simply returns name1 is equal to name2. So now we have a method called is same name. It takes two arguments and it simply returns if both names are same or not. It's a very trivial example, nonetheless a good example to show what static methods are. So those are the main differences between class methods and static methods. And you can access both of these using employee class directly. So let's go ahead and do that. So you can say employee dot uh, get twice max age, and let's go ahead and print this. And let's also call the other method, which is same name, and let's pass two names that are different. So this is obviously is going to print false, and then let's pass an instance where both are same, and in this case it is going to print true. So let's go ahead and run this and let's see what it prints. So there you go. As you can see, it executed the code on line 46. It printed twice the age, which is 400. Then it executed method called is same name, which is a static method, and it printed false and true respectively, like we expected. So that's on static methods and class methods. If I have to summarize the difference between the two, class methods are bound to a class. It can modify a class state and it can access only the class variables. They are generally used to create factory methods. Static methods, again similar to class methods, are bound to the class. It can't modify a class or an object state because it does not have implicit access to self or class, which can be used to access instance variables or class variables. And likewise, it can't access or modify class and instance variables. Instance methods that we saw in previous video again are bound to an object of the class, unlike class method and static method, which are bound to the class itself. Instance methods can modify an object state and can access and modify both class and instance variables. So these are the main differences between instance methods, class methods, and static methods. So now that we know class methods and static methods, let's move on to the last part, which is using data class decorator. So to do that, let's go ahead and remove most of the code here as we don't need it. And we will first import the data class, import data class decorator, and then we'll decorate this class with data class decorator. Once you do that, you can simply define the instance variable that you are interested in. Let's say in this case, you have name, which is of type string, and then age, which is of type int. Once you do that, it will automatically take name and age as instance variables. You don't have to define init. You don't have to take the arguments and assign it as self.name, self.age. The data class decorator is going to do that for you. So let's try that out. So here, if you see, I have created an employee class with I'm passing name as string and age as, and this should work fine. So go ahead and just print emp and just run this. There you go. So it printed name Aniket and age is equal to 30. As you can see, it also does few more things that it overrides the represent method, magic method inside the class so that it prints this employee string in a more readable format. Now you would ask, how would you go ahead and create a class variable? Now to do that, the simplest thing to do is just define a class variable here and do not set a type hinting to it. So let's say I define max age is equal to 200, and this is going to be our class variable. So let's go ahead and print that as well. So if I do, let's say employee dot max age, this is going to work. So yeah, if you see it, it printed 200. So one distinguishing criteria for data class decorator is if you add a type hint, then it is going to consider those as instance variables. If you don't, then it is going to consider that as class variable. Now, the other question that you might have is, what if you want to define a class variable which has a type? Okay, so to do that, you have to import another method called field, and then here you can define field for this class variable. So you can say that you do not have to use it in init. You do not have to use it in REPR magic method, and then you can also define default for it called 200. Now, once you do that, it is going to work just fine. So now you have defined the type of the variable of this class method, but you have instructed data class that it should not be used in init method, which means that this is not instance variable. It should not be used in REPR, which means it should not come when you try to print the object, and then the default value is 200. So now when I go ahead and run this, it is going to print the same thing as it did before. So this is just another way to do the same thing that I explained some time back. Now let's see the other way around. Like let's say if we do not add this field, then as we saw before, it is going to treat the max age as instance variable, and this is going to fail. So let's go ahead and try to run that and see. And you can see it says in it requires one positional argument called max age. So we are going to just try to let's say 100, or let's say 200 in our case. Now this is going to work. It is going to print EMP with both all three things, name, age, and max age. But this is going to fail because this is now an instance variable, and then you obviously cannot access it with the class name. So let's go ahead and run it. And you can see it printed employee object with the three things, and this failed. And then let's just go ahead and access it with the class with the object instance, and then it should actually go ahead and work. So there we go. So that's about it for this session. We'll discuss more concepts about classes and Pythons in general in subsequent videos. So stay tuned. Thank you.